Thank you so much. Thank you, Chris. Okay, so system design rounds are basically this and definitely requires lots of practice uh, to be able to ace these. So this is that.
Right.
Jean.
Yeah. So, system design questions are usually quite vague. It's quite scary if you haven't had much experience going through the interview before. But I think it being vague is actually advantageous to you because you can then scope it out and limit what you want to discuss. For the high-level overview of how to handle system design questions, usually you would start by clarifying requirements like the number of users, the devices that need to be used, the latency or like availability required. And then you describe some of the API operations that are needed. This will help to shape your design. So first, provide an overview of what it looks like, then delve into a more complicated part of the design so that you can show that you actually know your things, and then consider alternatives and trade-offs to what you have proposed. Yep, so I think we can move on to the mock interview now.
Yeah. So before we begin, just a disclaimer, this is a sample system design round. This is how we would have designed the chat app. It's not how the actual chat app in question, like WhatsApp, Telegram, are designed. This is just meant for our mock interview. And this is how we would have designed it in the spur of the moment when asked such a question. So yeah, let's move into the segment of mock interviewing. For the first part of this, Jean would be the interviewer and I would be the interviewee.
Right, so hey Saloni, let's begin our system design round. How would you design a chat app like WhatsApp, Facebook Messenger, or Telegram? Have you used any of these apps before?
Yes, hello. I have used these apps before. Let me just gather my thoughts for a moment. Yep. First, I would like to ask a couple of questions around chat apps. Are you considering more of one-on-one chats or group-based chats?
Both one-on-one and group-based chats.
I see. And would these be a mobile app or a web-based or both?
Both.
And how about the scale of that? Are you looking at a startup-ish or a massive scale app?
Let's say that it should support 50 million daily active users.
Okay. And for group chats, is there a group member limit?
Let's go with a maximum of 100 people.
And what features are important for the chat app? Like, can it support documents, sending images?
Right, so from what we have discussed, we want one-to-one chat, we want group chat, but I also want to see an online indicator, notifications for when the user is offline, and we can just support text messages, no need for attachments.
Text messages, okay. And is there a message character limit then?
Yes, the text length should be less than 100,000 characters.
And or about end-to-end encryption?
It's not required for now, but if there's time, we can discuss it.
Okay. And how long do we store the chat history?
You can assume that we'll store it forever.
Okay. So let me just conclude the requirements from what I gathered. So there will be one-on-one chat, also group chats with a maximum of 100 people, online indication whether the user is online or not. You would like to support multiple devices. So the same account can log into multiple devices at the same time, mobile and web. And push notifications because that's how chat apps usually are, they're instantaneous. And to support 15 million daily active users. Is that correct?
Yes.
So then I'll move on to the high level design. I'm thinking I will. Is it okay if I connect my iPad and project my screen so that I can draw on it?
Yeah, for sure.
So I'll just do that. You can see my screen. Okay. So in our system, there would be clients. Clients would be mobile apps or web apps, and these clients obviously wouldn't communicate to by like to each other, like laptops and mobile apps won't communicate to each other. They will have to go through a server where like mobile this client sends message to A, sends a message to B, it goes via the server and sends it back to B. And this server, let's call it the chat service. How this works is it will receive messages from clients, find the right recipient, and relay the message to the recipient. And if the recipient is not online, it will hold the message until the recipient is online, then they can receive the message.
Okay.
Something like that.
What's the network protocol between the client and server?
Network protocol can be, since the client is initiating the request for sending a message, I guess the common HTTP would suffice. And this would send the message to the server informing the who to send the message to.
Okay. Then what about from server to client?
Server to client. So yeah, I guess the normal HTTP would not work in this case because HTTP is client initiated. But in this case, it's from server to the recipient client. I am thinking of three options, which is polling, long polling, and WebSockets.
Yeah, which is appropriate then?
I actually haven't thought about this, but so let me just go through my thoughts with you. So for polling is when a client asks the server periodically, like, is there a message available? Is there a message available for me? So depending on the frequency, this can be quite costly. And we do want the receiver to get the message instantly. So the frequency in this case would be quite high. So I'm thinking, yeah, polling might not be the right one in this case. And also there might be periods of time like the night time or something when there aren't really any messages going on, and this might actually be using the server's resources because the constant polling. There might be optimizations around it, but on first thought. And then long polling is when it is slightly better than polling in the sense that the client will hold an open connection until a new message is received or it times out. But this might also be a problem because the client and the recipient client might not be connected to the same server. So it will be a bit more complicated in that sense, especially with load balancing in between. So like, how do we know if there is a message and who is connected to which? And also like, what if the receiver disconnects, and how do we make sure like, did he or she receive the message? This leads us to the last option that I provided, WebSocket connection. WebSocket is client initiated, and it can be bidirectional and persistent. So it starts off with a HTTP connection and upgrades to a WebSocket connection. the client can send a message via WebSocket to the server, and then the server can also send a message back to the client via WebSocket. So I guess,
yeah, are all the connections using WebSockets even calls like login or getting a user profile?
No, so not all require WebSockets. Features like logging in, accessing the user's profile can use the normal HTTP connections.
Okay.
So now we will move to the API design part of the interview. And for that, let me share my screen. We are now reversing our roles. I'll become the interviewer and Jean will become the interviewee. So, yeah, the API design. So yeah, hi Jean. Let's see what the API for such a system would look like.
Yeah, so usually after scoping the problem, we'll list some API operations that will help us to shape our design. So if you move on to the next slide, you'll see that these are some of the API operations that we'll need. We need to get the chats, whether private or group, for the user, and we need to be able to get the messages in those chats. We also need to be able to add a user or remove a user from a group. Then the user also needs to be able to send messages to the private chat or to the group itself. So in this case, you can see that clearly the send messages functions need to be connecting to the WebSockets, connecting through the WebSocket. So, and the rest of it can use HTTP calls. So we'll have at least two services, the web service and chat service. Since we also talked about having push notifications, we might want a notification service as well, just to decouple things and make it more resilient. Yeah, so now that we have an overview of this system, which we see requires a client, a chat server, a web server, and a notification server, I'll pass the time back to Saloni to draw the high-level system design.
Sorry, Jean. I would just like to clarify one thing in your API design before we move forward. For example, we have this send private message, and there's user ID, other user ID.
Yeah, let's just.
How do you mean user ID is like the sender ID and other user IDs?
Yeah, from the sender to the recipient. Yes, I could rename it to sender ID and recipient ID if that makes things clearer.
Yes. Yeah, that would be good. Nice. Okay. This looks good. And the object channel, what would that comprise of? Like, what does channel incorporate?
So in this case, I think it should actually be an array of group chats. So that would have the group ID and possibly the members that are within that group chat, or a last updated at timestamp, so that you can order a chat by, you can order the person's chats by like last seen. Yeah.
I see. So yeah, depending on the user UI itself, we can get the listed out text from the channel. Okay.
Right.
Nice. Okay. Then let's move on back to our high-level design interview. Okay.
Yep. So Saloni, could you draw the high-level system design?
Yeah. Back on my iPad. So until now, what we have is we have our clients, which is the mobile phone and web apps, and these would connect to mostly like a load balancer, which would be behind our API servers, like the login, the notification, the user profile services. And this would connect using HTTP. And yeah, and this would be stateless because they do not need anything here. And then the other actual messaging part where clients are communicating with each other, they would be using WebSocket connection. These are just the chat servers. WebSocket connection, two-way to communicate with each other. And this would be a stateful connection.
Right. You mentioned stateless and stateful. What does that mean?
Stateless protocol is one in which the receiver is not required to keep session state from previous requests. So the client can send relevant session state to the server in such a way that that request can be interpreted without reference to the prior request session state. And then the server will just retain that information. And HTTP is an example of a stateless protocol because each request is executed independent of what was before it. So you log in, when you access the user ID, you still have to be authenticated and authorized to retrieve this user's data. So this implies that once a transaction is complete, the connection between the browser and the server is also terminated.
Okay, so why would you choose stateless over stateful or vice versa?
For things like signing up, logging in, and like assessing user profile, there's no need to know the previous, like what was previously sent. So for these, it makes sense for it to be stateless. Like, so every request has to be authorized and authenticated. You don't have to persist anything per se that, oh, last time you have already authenticated, so now you don't need to authenticate again, kind of things. And yeah, therefore it makes sense for these features. But for like the WebSocket connection, that is already maintaining a persistent network connection. So for that, it has to be stateful.
Okay, yeah, I got that. So how does the client know which server to connect to?
So in the stateful case, right? Like, so WebSocket connection case, like how does this client know which chat server to connect to?
Yeah.
For that, I guess there's a concept of service discovery, and its job is to recommend the best chat server for a client based on criteria like geographical location, server availability and capacity. And there are open source solutions like these already, like Apache Zookeeper. It will first register all the chat servers available, and then it picks the best one for a client. So I can just draw this out. How it will look like is our clients will do like the normal HTTP connection to our load balancer. And the load balancer, after authenticating and stuff with the API servers, it will then call this thing called the service discovery, which is basically a bunch of servers registered like 1, 2, 3, 4. Based on the criteria, it will select maybe chat server 2, and then this chat server 2 is sent to the detailed chat server 2 is sent to the client, and then the client will establish a WebSocket connection to chat server 2.
Okay, in this case, you have a load balancer and you have service discovery. Why do you need service discovery? There's only one service, just the chat server.
Yeah, maybe it's like the terminology thing. There is one service, chat service, but there are multiple servers. So in this case, service discovery refers to the server per se. And I guess you're also asking, like, load balancer also does these kind of roles where it decides which server to route to. Yes, load balancer can do that as well, but in this case, there would probably be a specific custom criteria list and logic to determine which client should connect to which server. So therefore, I would suggest to use a separate microservice itself called service discovery, which is the zookeeper, which would select for you.
Okay, fair. Let's move on. Can you now go through how the one-to-one message flow might look like?
One-to-one message flow. So let's, for example, see user A wants to send a message to user B. So user A is connected to chat server 1 and it sends the message, and then chat server 1 would then put it in a message queue. So there are these messages queued up here. And this message queue will first store it in the database, store the message in the database so that it doesn't get lost. And then it will forward the message to the respective chat server. So for example, user B, we know is connected to chat server 2. So it will forward the message to chat server 2. If they're online, it might be that they are offline, then we just push it to the push notification server. Yeah, if it's offline. Yeah, this is the database.
Yeah. Okay. We have a question from E who asks if client A has been connected to chat server A, for future requests, will the client have to use the same server?
So for future, not necessary. It will determine again via the service discovery, like whichever's closer and things like that. There's nothing in chat server 1 that user A has to connect to it. It's just at that point in time, it is the closest, it's the most available for it, and it can hold a WebSocket connection.
Within the period of time that the WebSocket connection is open, the request will all go through the same connection, if that's what you're asking. But once that connection has been terminated, they can freely pick another server. Yeah, okay, let's move on. So you have your database here. What kind of database would you use? What will your database look like?
For database, I would first consider what kind of data we want to store. So in this case, it's the messages, because this is the messages queue. So for messages, the amount of messages we would like to store is enormous, because we want to store the entire chat history of every single user between each other. So yeah, that's definitely a large amount. And users will also search their past history, at least on WhatsApp. I do that a lot. So that would be, searching is definitely required. And the read to write ratio of these messages is 1-to-1, because as you're typing in, you're writing, you're also reading the messages. And yeah, I would also, in this case, I would then lean towards key value store, because it allows horizontal scaling and also lower latency to access data. And relational DB would turn out to be more expensive in like the long term because indexes would grow extremely large because of the amount of data that we have.
Okay.
Yeah.
And can you tell me about your message table? What would that look like?
Message table would then be the key in this case would be the message ID itself, which we can use UUID. I'm choosing UUID here because I want the ID to be able to tell the chronology of the messages. And so this is the primary key. And then there will be other things like message, to, message, from, the actual content of the message itself, which that's just like a string. Then there would be created at. We're not using the timestamp created at as the key itself, or like to use it to do the chronology, because the message can be created at the same time by two clients. But which like, so yeah, when you save it into DB, that the message ID can make sense to show the actual chronology.
But your UUID
Yeah.
is random? Is it ordered?
It will, as in how I'm storing it in the DB.
Yeah, you said that it has to help you determine the chronological sequence.
Yeah, so when I refer to UUID, I mean like the time in the time itself when it was saved into DB, that UUID, it would be, yeah, basically I want it to be unique and sortable. So a UUID is sortable by time.
Okay, okay.
It's sortable, not by time. It's sortable.
Right.
Yeah, this would be the message table.
Yeah, okay. And how about group chats? How would that look
Group
like?
chats. So there would also be a separate group message table. For this, I would actually have the group message ID similarly, an ID here, which can also be like UID or something. And then also the group ID itself. So I would use both of these as like the composite key, not primary key, but composite key. Both of
Okay.
these. And then of course the other stuff like the message from content and created at. I'm using the composite key here instead of just a group message ID because I foresee that because there are so many messages coming in, by making a composite ID of the group message ID and the group ID itself, I can allow the group message ID to be non-unique. So it only has to be unique within a group, doesn't have to be unique across the entire group message table.
Okay.
Just to reduce the number of unique IDs we have to generate.
Right. Then how would you generate the message ID?
Yeah. So basically, we want the message ID to be unique and sortable by time. So like basically every row that is entered into these two tables have to be the ID has to be higher than the ones existing there so that we know how to chronologically put them. So my first idea would be to use something like the auto increment in MySQL, but NoSQL does not usually come with such features. So I'm thinking maybe a local sequence number generator service where local meaning an ID only has to be unique within a group or a one-to-one channel. It doesn't have to be unique across all messages in our database. So if user A has chats with user A, B, and C and D, the messages have to be unique only within each of these channels. So the same ID 1 can also appear here, can also appear here. 2 can also appear here and here. It doesn't, and all of these are still different. The one from here is different from the one from here. So this would really reduce how many unique IDs have to produce. This is what I can think of right now.
Okay. Let's move on to how you might handle multiple devices and syncing messages across the devices.
Okay. This would be basically like I have user A using a phone and then also user A using a laptop to access the same chats. So usually how this will happen is they would so ideally they would be connected to the same chat server, most likely because of our criteria it would be. And yeah, then this chat server is connected to our DB and then that's where it's getting all the information from. So if they want to see the latest messages across both, so I guess we can use some concept of like here it will hold this variable called current maximum ID. And here also there will be a current maximum ID. So for example, this particular user uses the laptop more than the mobile phone. So we would give the current maximum ID, message ID in the laptop is maybe a random number 841. And the current maximum on the phone is 632. These are IDs. So user A's mobile phone client will just ask for give me all the messages which are greater than 632. And on the other side, the laptop will ask, give me all the messages which are greater than 841. That's how they can sync sync it across their devices.
Yeah, okay. And does this work for group chats?
For group chats, it will be a bit tougher. But for small group chats, like let's start small first. For small group chats, I guess we can assign like a queue for each recipient. So group chats in the sense, oh, this is user A and they are in a group with user B and user C. So user A is sending a message. They would connect to chat server 1 and in our system itself, there would be separate queues for user B and a separate queue for user C, where all of these messages are going into, and basically there will be a chat server here as well. So random chat servers 4 and 2. And that's how they would get their messages this way. So like I'm using a message queue here because the job, like it is like a guarantee that okay, that once I send it to the queue, it will send it out to the user when they're online or whenever they receive it in that chronology. Also because with a queue they can, like, the messages are not lost, we are still saving it, and this message queue would be like an inbox per se for the group members, and we would have one for each of them, which is a problem in this case because yeah, it only works for small groups and not larger groups. So I actually know that WeChat uses something like this to handle their group chats, like how their group chats work. So that's why they actually have a limit on the group member size. And since we also have a limit of 100 members in every group, I think this should work. Having a queue for with that much data is not that expensive.
Okay, fair. Yeah, so there were a couple of questions in the chat. One was about the difference between horizontal and vertical scaling, if you could answer that. What the difference between horizontal and vertical scaling is.
Horizontal and vertical scaling. Okay. Wait, should we take the questions maybe towards the end? Let's complete our
Alright, sure.
presentation first. Sorry, attendees.
Yeah, okay, cool.
Because I was kind of in a flow.
Then I
okay.
can just wrap up like
Yep.
the interview, right? So to wrap up, we have seen how we can handle chats in real time with both users and groups. And we've also looked at how message IDs can be synchronized over the devices. But there are also some non-functional requirements that we need to be aware of. And so let's discuss this for a bit. Yeah. So the first question we usually ask is if our system is scalable. So in this case, we are using a NoSQL DB. So that can handle high numbers of read, write IO, and it can scale horizontally, meaning you can add many more servers to it. And our servers are behind a load balancer, so they can scale horizontally as well. And to further optimize it, we might want to add a cache on the client side for the most frequently accessed data, like the most recent 10 chats for a particular user. After talking about scalability, the next question the interviewer will usually ask is like, is your system highly available? So when we talk about high availability, we are looking out for points where there could be a single point of failure. But in this case, we have multiple instances of the servers, and we can have replicas of the DB to reduce that risk. And to protect our servers from excessive traffic or attacks, we can also introduce reverse proxies like Cloudflare, which can help to throttle traffic and provide a web application firewall that can shield our servers from attacks. So after we have designed all of these things, right, it's also important to monitor our system for errors or downtime. And some of the tools that we can use are Datadog, Grafana, and PagerDuty to let us know if there are any issues with the system. Right.
Yeah. Then before we end off, like the mock interview session has ended with this, but before we do move on to the Q&A part, let's just analyze like what was happening during this interview session. This is usually what we do in our interview ready sessions. So yeah, a lot of things happened. I probably spoke too much, and some things probably weren't too clear, but this is how a system design interview is. There can be a lot of questions, there can be a lot of ambiguity. The interviewer can ask you some follow-up questions if they don't understand certain things. And your design doesn't have to be the most perfect. It is what you can think of at the moment to solve the problem on hand. So it's okay not to know some things. For example, when I was asked how would I handle the large groups, how do I send messages to large groups from user A to all the members in a group? I did not actually know. I only knew how to handle small groups where I proposed to use the message queue thing. So I was honest about it. From what I know, WeChat uses this way, and they have a limit on their members. So at this moment, I can't think of any other solution. So yeah, it's okay not to know some things, and be open to suggestions. So for example, in Jean's case, she did use words like user ID or other user ID. I did clarify with her as the interviewer, like, oh, do you mean sender ID as the user ID? She was actually receptive to it. She said, oh, actually, that makes sense. Let me rename it for clarity. Right. So that gave me a good opinion of Jean, that she is receptive to feedback and isn't very fixated on, oh no, I always name user ID as user ID, things like that. And also you would have noticed along the way, I would check with the interviewer that if I'm on the right track. Like after clarifying the requirements, I asked, is this what you were intending as well? So then the answer was right and I went in that direction. And also know that interviewers understand that you're designing this system on the spot. So you have to communicate your thoughts. So if you remember when I did the long polling WebSocket, I actually did not know which one would fit this case before I said it. So then I went through each of them like how I would in my mind, just communicated my thoughts and then stuck to, okay, WebSocket makes more sense in this case. Yeah, and yeah, that is about it. And yeah, there can be additional talking points if there was more time for this interview. We might also be talking about extending to support photos and videos besides the text. Also caching of the messages on the client side. I think Jean did talk about it. So to make it a bit more, to reduce the data transfer between the client, and so we can do caching on the client side. And to improve load time, we can also use geography distributed network to cache the user's data and groups for better load time. So these are just some of the things that could be asked as well. And then once again, disclaimer, this is just a sample system. This is not how all chat apps are designed. This is how I would design in the short period of time that I could come up with this solution. And Jean as well. So now we can move to the Q&A part. Okay. Yep. Chris, I will just put in the YouTube channel in a bit. And that sounds good. Live transcriptions noted. I guess we will have a look at it. I'll save your link that you sent. Yeah. Difference between horizontal and vertical scaling. Okay. So horizontal scaling, like the name suggests, it is just basically adding on new machines. So I think I mentioned horizontal scaling in key value DB's case. So if you have more data coming in, because the data is going to be so huge, you can just add more machines to fit in our data. As opposed to vertical scaling, is basically using a bigger computer, basically, or a bigger database. Like if you have 1 terabyte of DB, then use 2 terabyte DB or a 10 terabyte DB instead of using 10 1 TB machines. That would be horizontal scaling. Jean, was that clear enough? Do you think?
I mean, yeah, but whoever asked that question, was that clear for you? Was that Chris?
Yes. Yeah, the next question, thanks.
Yeah. Okay. Message ID, UUID sortable by time. Let me just clarify this. So this is what I came up with on the spot. Usually UUIDs are IDs which represent the current time, if I'm not wrong. So that's what I meant. And yeah, by using such IDs, you can sort them by time. So you can know that this message came before this one. It can be chronological on your chat app. So yeah, that's what I meant. Sortable by time. Chronology determined by timestamp. Wait, is that a question? The chronology determined by timestamp and UUID. Okay, I'll just go to the next one first. For group message, will you use a surrogate key instead of composite key? Okay, I can't remember what a surrogate key is, but I am using a key. Yeah.
Surrogate key means you add one more, for example, you just add one more ID, maybe group composite ID, then you just add the
right.
database.
Correct. Yes, I remember now. I guess that is fine as well, but in my case, I used a composite key because I wanted to reduce the number of IDs I will generate for each message. So within a group, there will be all these messages, and these messages ID would just have to be unique within a group. So in my case, it makes sense to be group message ID plus group ID as the composite key. But in other solutions, that you could have used a surrogate key as well. So it depends. Yeah, hope that was clear. If you have anything to add, just let me know.
Right. I think that was fair. Like it's not an either or. It's not an either or situation. It depends on what you're trying to optimize for. If you had used a surrogate key, it would basically be the same thing as a UUID, the message ID being a UUID across both the message table and group messages table. In your case, that will work because you have a separate ID generation service. But if we're using something that was something that doesn't support IDs distributed across different servers, then that wouldn't work. Yeah.
So Ray is asking, vertical scaling referred to as scale up. Oh, okay, you're answering. Nice. Scale up means adding more power. Horizontal would be scale out. Nice. That's what I also meant. Thank you, Ray. I love to see audience helping audience. Nice. Actually, is there a difference in the meaning of system design and system architecture? Yeah, I think this is very subjective. Different teams, different companies, different people use these terms varyingly. But I would say system architecture does cover database still. I don't think there's a difference between the two, in my opinion. But yeah, different people and companies do have different terminologies for these things. We'll have to clarify. But what we are doing here is the more popular system design round in like the more bigger companies. You will see on YouTube, there will be a whole lot of these. Yeah. Datadog, Grafana, and I can't hear the last one.
Yeah, I mentioned PagerDuty.
Oh.
Basically
Okay.
just observability platforms. Yeah.
Oh, nice.
There was
Okay.
a question that Chris asked about what if the interviewer asks about which cloud to use. So it depends on your experience, right? So there are different ways of answering this. You can look at it from like whether the cloud platform is widely used, like whether there's an ecosystem of tools that you can tap on that are already integrated with the cloud. For most of the bigger platforms like Azure, Google Cloud, and AWS, it really they're all like fully featured. You can use any of them. So then you will look at, okay, what does the existing company use? Does it fit into what they're currently using, and what their requirements are? Then you could also look at your own experience with the cloud. Like if you're more familiar with AWS, let's say, then you can talk about the different services that you know could be useful for that particular problem that you're solving. Yeah, I hope that helped. Did we miss questions? On-prem versus cloud. I'm not sure whether they would ask. I've never had that being asked, but usually companies would use on-prem if they have more confidential data that they don't want to put on cloud, or if let's say data transfer cost is prohibitively high, like if you needed to transfer data between your cloud and on-premise services. What else? Yeah, I guess on-prem is usually
message. Like when you say when would they ask on-prem versus cloud? So yeah, it really depends on the company. They might definitely, like this is a very popular question as well. Like when do you use the cloud, basically? So I definitely do read up on that as well. Like the pros and cons. When do you do what? And how does message caching on the client side work? I'll try to provide like a gist of it. At least the one I was referring to in my slides for client side caching would be, for example, your mobile app has WhatsApp on it. They can actually save a cache. Like it might just be like a text, a TXT file or something. A bad way of storing things, but like a TXT file with like things like the current message ID for each of the channels. Like with user B, your current message ID is 5. With user C, your current message ID is 10. So this is something you are caching on your client side. Like we don't know about it from the backend side, we don't know about it, but it's on your client. So other things you can cache is like the last 20 chats that you usually, not that's too much. The last 5 recent chats and its last 10 messages each. You can cache that on your phone so that when you open, you don't see a blank screen. You'll actually see the last messages that you've already read, and then to refresh and add in the new messages. So that can be message caching on the client side. Hope that provides a summary of client side caching. Certifications for system design. I personally do not have any certification, but I do know about my peers who have done AWS certification, AWS cloud certification, if I'm not wrong, the one for software developers, basically. And they did mention that it is very useful to understanding and designing a system. So I would definitely recommend it. I personally have not done it though.
I took the solutions architect cert for both AWS and Google. So it's more like it's not about system design per se, but knowing what systems are available outside so that you can put it together. And the best way to go to pass a system design interview is to have thought about the system itself and how you would design it. So read up. You don't really need a certificate for it.
Exactly. And then I did put in a feedback form for this session. Like, we would definitely love to know how we can further improve our sessions and what's working, what's not working, so that next year our sessions can be much more better. So yeah, please do help to fill in the feedback form. What is serverless for a platform like yours? What are you referring to, Chris?
Because I saw that you can create a serverless WhatsApp platform on AWS. So I don't know what is serverless.
Sorry, can you repeat that?
What is serverless? So usually when you have your app running, right, you will put it on a machine and your machine will keep serving the app so people can connect to it. But there are other services. One that Brian has brought up is like Lambda functions. So you don't have a long running machine. You use the cloud to spin up a particular function that serves the HTTP request that's coming to your app. So you're only paying per request instead of like paying for a machine that's running all the time. So this can help you reduce your costs. The WhatsApp messages can be done using Lambda functions in AWS. I suppose if you want to send WhatsApp messages, yes, you can use Lambda functions, but to process the WhatsApp messages and distribute them to other clients, it's not quite possible.
So yeah, we are running over our time. But yes, thank you for the questions. If you have more questions for us, our meetup channel where you should have signed up for this actually has a comment section. You can write us a comment and Jean and I will try to answer it. Or for system design concepts, I personally rely on YouTube. So you can just YouTube these concepts, and there are like a lot of people explaining it in very simple terms and more advanced terms. So please do use these resources. And yeah, I do see some thank you messages. So yes, thank you as well for coming in live. And our session is recorded, so it would be on YouTube. I've put in the YouTube link as well. You can search for Interview Ready Series Women Who Code, and you should be able to find it on YouTube. Thank you so much, everyone. And yeah, you can connect to us at WomenWhoCode Singapore for Women Who Code, and our email is singapore@womenwhocode.com. Let us know if you need anything. Thank you.
Thanks, bye.